Okay, we throw a ball and then it will come back to the same point. So this is our xy coordinate. The first thing that you need to show, this is the positive x and positive y, and it should be dashed line. So the v0x is v0 sine theta. Okay, sine theta. And v0y is v0 cosine theta. This one's. v0x is this one. So v0, the magnitude is 12. It will be 12 sine theta. v0 or vy0 is 12 cos theta. 0 means as t equal to 0. So when this ball go up and then come back, the acceleration is constant and it is equal to minus g minus 9.81. So vy is equal to vy0 minus gt. So the important point is when it comes back, the velocity is in opposite direction in the y. So for example, if we have 12 cos theta, it will be minus 12 cos theta. So g will be the same, 9.81, and t is t final. It means that how long does it take to reach, to go up and come down. Again, for vx, the acceleration in the x direction is constant, minus 0.4. Therefore, the velocity at this point, it should be opposite from the initial ones. For example, if it is 12 sine theta, it will be minus 12 sine theta, the final one. So we just substitute everything. Vx minus 12 sine theta, vx 0, 12 sine theta, as you see here. And instead of t, from the first equation, we will find the t final. Okay. So this 12 cos theta goes to the other side, left hand side. It will be minus 24 cos theta divided by minus 9.81. It will be 2.45. And then TF will be equal to this. So we will substitute this one here. And tan theta will be equal to this number. Or theta will be equal to this one. This is one solutions. Okay, now I want to explain something. If we have a constant acceleration, for example, here in the y directions, okay? In the x direction here, when we throw a projectile, the acceleration in the x is not is 0, okay? But here I'm talking about the constant and non-zero. So assume that it will reach the 0 velocity at this point, at the peak point. Actually the vy, not vx, because we have vx here at this point. So at this point and this point, we have opposite directions but the same magnitude. Okay, remember this. And again here, based on symmetry, vy at this point is opposite of this point. For example, if this is 10, it will be minus 10 at this point. Because of this, when it goes up, it will reach 0 and then it come back. It will be based on the symmetry, the same distance from the peak point in the y direction we have. So vy will be, vy at the final point will be minus vy 0. And for the same thing for vx 0, because we have a ay here, acceleration at this one. The acceleration at in the x direction is not equal to 0.